Yeah.
It's time.
It's time.
Oh,
We're in.
It's time.
Okay.
Hello.
Yes. Tell us who you are.
Hello, this is Silicon Valley for the Interest Group, and I'm CH King. And so I have this morning session on the genealogy. But a couple of weeks ago, a friend gave me several links. He said, "Oh, you should look at this link." So I clicked on the first one, and it was our broadcast last month. And it was my session. Okay, I'll look at it. I'll look at it. So I did just look around and look at it, and oh boy, that was a torture. So my wife said, see how much I suffer for these years. So I have to apologize to all the listeners that it was really bad. And I really appreciate that you guys suffer through all these talks. So I thought, well, last week I was making this presentation in our Bible study group. And it was a Chinese Bible study. So I did everything in Chinese. And I thought, well, I'm not doing so well in English. Why not do it in Chinese this time? Okay, so then someday
Google can almost do. Oh, you did.
There is genealogy in fourth. Yes. Okay, so that's in Chinese. And 历代至上1到9章气血. Okay, so that's for my Chinese friend out there. I don't know how many of them are watching. Like this is
where are we?
And I think I just don't have to read it in Chinese and that's English. Okay. This is basically, I was reading this Chronicles Bible, and this Chronicle, First Chronicle 1, chapter 1 to 9. It's really not interesting. But I found, yeah, I saw in it a fourth program. Okay, yeah, it's a database, and it's probably written in fourth. So I talk a little bit about if we are going to design a database for the genealogy of this in these chapters. How should we go doing it? And of course, I talked a little bit of fourth, the words and dictionary. These are the data structures in fourth, and I found that there's a great similarity in genealogy database, the fourth dictionary. So based on fourth, the structure of the fourth words and fourth dictionary, we can adapt it to build a genealogy database. I show you how to compile it. And how a database basically got two elements. You have to compile the database, and you have to be able to search it to find information you want. And this is, of course, I want to, for my Chinese friend, I want to emphasize to them that Chinese is the only computer language which can be adopted. Which can be written in Chinese and used in Chinese. So I think that many of our friends in Taiwan have already been convinced of it. I just hope that a more general Chinese audience might be interested. Okay, First Chronicle, chapter 1 to 9. This is one of the most interesting passages in the Bible. It contains about 1,000 names and their genealogy relationships. I saw it a fourth program, and this program is describing a relational database. So I just show you a little bit about the English original passages. So it's verse chapter 1, verse 28. The son of Abraham, Isaac, and Emmanuel. These were the descendants. These were their descendants. They were the firstborn of Ismael. I don't know. I can't read.
Yes. Neither can we.
So these are just the sons of them, some of the father. Abraham was the father, and so it's not exactly programming language, but you can see it. It's describing a database. So I look through it and say, well, it needs pre-processing. Okay, so this is in English or in Chinese, but it's in the form of a natural language, and the natural language does not lend itself readily to be compiled by any program. Okay? But I can go through all the passages, do the pre-processing myself, and extract essential data out of the passages. And so the data I extract is like every line of code, every line of information. It starts with the name of the father, and then his sons, however many of them. So if you, that's all the information, all the genealogy information that's being extracted out, and it's the complete set of information that you need to build the database. And so, I just extract everything into lines. Every line has a father and a variable length, variable number of sons. And if you look at it, you can see a for program. Could you? Colon, the father, sons, and semicolon, right? That's a for program. It depends on how you interpret, how you compile. But structurally, we have a header, a father, and a whole bunch of sons. So this data I can compile, and I can turn it into a database and use. And fourth, so the essence of a database is that you have data. You have to organize the data in certain ways so it can be stored and retrieved conveniently by the computer. And the human interface is core. You have to devise some ways that you can search the database and present relevant information to the user. So that's the essence. Okay, so the fourth language or a fourth system contains the essence of the database. So we have these ways to structure information, and the fourth compiler can organize the data into memory in any way you want it. And the fourth interpreter It's already a search engine, okay? And you can search the database and present the information. Okay, the searching is contained in the fourth language for system. How you can present information, that's an application. Okay. So the fourth, the basic element are words. Okay. So fourth is based on words. Words as names and execution behaviors. And the fourth, interpreter can interpret word lists. Basically, the interpreter, you give it a list of words, it just execute or interpret words in sequence. And fourth, compiler works similarly. You give it a word list, and it can compile and give it a new name, and you have a new word. So all the words are linked and stored in dictionary. So this is the basic structure of fourth, and it lends itself very well to the building of a database. So here, I just use each word as an example. How words are organized in the dictionary. And every word we have a record. And in the record we have a new field, we have a name field, and we have a code field or execution field. So many different forms organizing differently, but this is the one of the ways to do it. You have four words in a dictionary. And all the words are linked together in a linear list, starting with the context. If you fetch the address in the context, that points to the name field. And you compare the name. If that's not the one you are interested, you go to the link field, which points to the name field of network. And so you go down to the list until you find the word you wanted, or you reach the end of the dictionary, which the link field is a 0, indicating that this is the end of this. And then the interpreter has to decide if it reached the end of the list, what we do. You abort. You got an error message or do something. But this is the complete structure of a dictionary. It has many records, and each record has a new field, name field, which allows the language to operate very smoothly. Okay, so we want to use the fourth dictionary to implement genealogical database. Okay, so fourth already has the linking mechanism, so we can define lots of words and link them together into a list. And for the genealogy, what we need, I have been struggled with the data for a long time. How do I present this data? And when I compile a genealogy database, what kind of information do I have to include in the system? So you have a father and a bunch of sons, and he may not have a son at all. Okay, so these are all the conditions you have to deal with. And Of course, the real problem is each person may have a different number of sons. So how would you organize your data to, a father has a bunch of sons? How do you represent them in the database? And after much thinking and experimenting, I found out that here is the bare minimum of information you have to keep. And also, there will be a complete set of database. Each word needs a name field, a name field. This is for the searching. And they need to have a father field, which points to the record of its father, of his father. And it has to, he may have many different sons, but if we organize the dictionary so that all the sons are in consecutive records, then you only have to know where the first son is. Okay, so in each record,
these sons,
yes,
they might have variable length records.
yes, you can use variable length records
Or word.
Yeah. We can compile variable length records, but it's very difficult to include variable length records.
I'm sorry, I'm not following how you account for anyone's sons. I thought those would just go in the parameter field. You have a few fixed length words, born, died, spouse, son, and then son, and a definite number of sons. And then here would take care of everything. I thought that's what you were doing.
No.
Okay.
This to handle a variable length list is much more difficult, and it's difficult to compile. It's difficult to interpret. So let me okay. So you only have to have, for each person, you only have to remember its father and its first son, because if all the sons are compiled in consecutive records, okay, so if you find the first son, you can go to the next one and next one and next one to see who
Which father? Same father?
Okay. Yeah, just compare the fathers. If they have the same father, then they are brothers. If you come to a record that the father is different, then you know it's the end of the son list. Okay? Okay. Yeah. So this way, it's very simple. The database will be very simple, very easy to compile, and very easy to interpret. Okay. Well, the fourth compiler, we can just use the fourth compiler to build all the records, and the fourth interpreter can search the entire dictionary and find out the relevant information. So here is the structure of the genealogy words. So we, just like fourth, we have name field, and we have name field, and name field, of course, is variable length. And you have father field and the first son field. So all these things are linked together. And the compiler compiles from the earliest person and down. So when you are searching the dictionary, you search from the latest one. And there are many names are the same, but the relationship of a son to his father, generally the assumption is the father would be found earlier than the son. So you search backward for the name, and you find the first name, matching name, that must be the father, his father. Okay. There might be other persons of the same name in the dictionary, but you only have to go back to the nearest match. Kind of okay.
Yeah.
All right. So, how do you compile? So we have the data organized in lines. So each line starts with a father and a whole bunch of sons. But for example, we have this one line, Judah. His name is and Onan, and Sheila, and Perez, and Zerah. He has 5 sons. So, okay. So when I go down when I first get Judah, I would search the current dictionary, see if there's any Judah there. Okay. And Judah was the son of Jacob or Israel. So Israel has already been compiled. So you search back, you will find Judah. And so that's, I know the father, Judah is a son of Jacob. So I feel currently I found the record of Judah. And now I'm going to compile a son. And the first son, I'm just right at the code field of the next earth. And the earth would go back and fill the first son field in Judah's record. Right? And in the record of earth, I knew his father is Judah. So I filled Judah's record in his father field. Okay. And then the next one is the Judah's first son. I don't know yet. So just put a 0 there. Okay. So just go down to the list of the sons. And all these 5 sons, they share the same father field of Judah. But their son field are all empty now. So later on, if I find any of the son, I will go back and fill the son name, the son field of individual sons. Right? So we search the dictionary for Judah. And if we find Judah, we have the CFA of Judah. Okay, then we read the names of Judah's sons. And for each of Judah's sons, we have make a new record and fill the father name, the father field of all his sons with Judah's CFA. So this way, I can go through the list. Judah is already somebody else's son. So I have to resolve the son field of his father, and then I compile the records of his sons. So this way, you just go through the entire database, and you can compile each and every one down to the last one. And to search the person, I have make up the word Judah. Look up. This is a 4th word. It just searches the dictionary and returns the CFA of whoever the person you are interested in. Okay, since I built the entire database based on the Chinese text, everyone the names are in Chinese. I can just build the same thing in English as well. So there's no problem in building a Chinese genealogy database. And when I search, you cannot, if you are familiar with the fourth word structure, you know you cannot type the name of any person and just use the fourth interpreter to interpret that person, because in the record, in a fourth word, the CFA is points to an executable routine. So that's the execution behavior. But in the genealogy records, there's no execution field. There's no code in it. There's only data. Okay, so you really cannot execute any of the name as a fourth word. What you can do is find the code field which has these two records in it. So you find the code field, and with that code field, then you can call. You can ask, what are this person's ancestors, or you can ask for sons, or you can ask them for grandsons. Okay, and so when I wrote the program, I used lookup ancestors, sons, and grandsons. But I can just redefine all these commands with the Chinese commands. So the Chinese, if he can type in Chinese characters, he can actually use this database to look up information of the country.
So you're saying in English you can't?
Yes, yes, they are the same.
Oh,
Okay. But since the database is all built on Chinese, so you can search, you can get the information, but the information are all in Chinese. Okay. And I didn't do it with the English Bible text. So there's no information, no English information, only Chinese. Okay, so I will use a demo, and I will start I'm writing everything in F#. So start F#, and all the make file is in what we call .fex file, for executing file. So this calls add.fex, and it will compile the text in the add text that file. So everything can be compiled, and I can show you basically use the fourth words to show the fourth dictionary. You can see all the words that compiled into this database. And then I can show you if I look up Judah and return the CFA, or I can type the Chinese words, 请问刘大. You can see this database is in the both in the English mode and in the Chinese mode. Okay. Any comments, any questions?
I'm just amazed that you actually are able to do a database right in forth, in terms of forth.
Yes. Usually
You don't have the record because forth has that capability.
Exactly, exactly. That's what I saw. You know, when you look at this data, father, son, 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 right? It's just a fourth program, right?
Yeah.
So you can use fourth. It's so close to fourth, but you only have to change a little bit to get it compiled and make it useful.
Would you like to redo it? Because I have an idea with does, that you should include not only the bare genealogy, but birth, death, birthplace, spouse, and such, by using the, and also, if you put the sons out in the parameter field, the dictionary doesn't care about variable length records. So, I'll see you next time.
The
Okay.
problem that you took a simplistic example.
Yes. Yes.
I've done genealogy stuff and written some of the programs.
Mhm.
Where this will fall to pieces
Mhm.
is if you put the spouse in.
Oh,
Because now you can have multiple spouses for a single person.
yes,
And if you go the does approach, you can have multiple code fields.
Yeah.
It just comes more complex.
Yeah, you can get as complicated as you want,
Right.
but
Right.
you know this structure, you just design the thing properly
Right.
in the code field. Now we only have two fields, two fixed length fields,
Right.
but there's no reason why you cannot have variable length. The variable length fields having lots of information.
Right. You'd have to go extra stuff, and it just becomes more complex.
Yes.
And trust me, genealogy databases are real complex in that
Yes,
way.
if you want to be,
If you want to do reality of them, they get people do all sorts of things. You've got crossbreeding all over the place.
You know, a person can have a variable number of sons.
Yes.
He can have a variable number of wives.
Yep. And they can cross marry. Oh, it gets really messy.
All right. So let's don't get I just want to show you something that I captured. So here, I compiled the whole thing, and I'll say 请问犹大, that's look up Judah, okay? And it returns a strange number, that's a CFA.
Okay.
And so I say ancestors, and then it will display all the ancestors from Judah and back to Adam.
Yeah.
Okay. And you can ask, because when I do the ancestor, I do not destroy that CFA. So you can keep on asking the sons and grandsons. Okay? So yeah, I can do even more.
Okay. Good. Yeah.
I think that with grandson, you have pretty much the the capability. If you want to go deeper, you can go any depth. And then you can say, well, look up Abraham. In terms of, I thought I destroyed that Judah's CFA, and then ask for Abraham. So it returns the Abraham's CFA, and I can ask ancestors. I can ask sons, and I can ask grandsons. Okay, so let me just go up here and go to the form and see if I can. And go to the chart, everything's in this Adam. And let me show you the text. So this is the source of the original text source of the genealogy. And then you have the father and a bunch of sons. Many of them have many sons. But it doesn't matter, okay? As many sons as you wish. Because sons are compiled as consecutive records after the father. Not necessarily after the father. The father may be way ahead, but then father's record is way up there, and then follows at this point all the sons follow. So this is the date the text file that I will build. I will compile and build the genealogy. Okay, here, come up here. This is the F sharp. Or F sharp. Okay, then I need the wrong folder. That was another thing. Let me see. Okay, that one. Okay, here I got that your .fx files. The top one is one. Which has this one and it starts. Show you more information with the video screen. And this is starting point of compilation. Well, it started, you need some utilities. That shop is very small, very clean. So you need lots of help to deal with the complexities in Windows. The files, you have to open the file and do all the things. So it finally loads up everything and then starts compile. What it reports are two things: no link and redefine. No link is because you go find a name, you search back, nobody's there, okay, and there's no record of it. So this you have to supposedly everybody was born from Adam, right? But the database have gaps. Some of them, they just start with somebody and didn't mention his father or his ancestor. So there's no record of this guy currently at that point. So it reports a no link of what we do if there's no father, there's no record of his father. So I just start a new record without the father field, without the son field. So it is a new linked list. Okay. So he's somebody who has sons, but we don't know his father. And then the redefines. Many names has been redefined. That's because you search back into the the duplicates. The names, many names are duplicates. So I think that the Hebrew is a small tribe, and so they share. A lot of people share the same name. So it's natural in a big group of people that they share the same name. But it's not a problem here because generally when we just read the text in Bible, it says the father, it goes down on the list. So it's chronologically arranged. So when you find somebody, find a name, you search back. If it's linked, you ought to be able to find it. If you cannot find it, you have to start a new link. So this is not my problem. This is the the database itself, the information. We don't have enough information on everybody. But when you see duplicates, the relevant person is the one which is closest to it. Okay. So, and there are may have many persons of the same name, but if they are too far away, they cannot be related. Okay, so here is the result of the compilation. You see, these are the problems that we have to deal with when there's no link or when there's new words redefined. Okay, so let me show you the words.
Oh.
Okay, so at the bottom, these are all the fourth words. Okay, and you can see the fourth, this probably up to here, new and forget. So down there, that's the fourth core, the core words. And up there, these are all Windows, Windows interface. Many different words people access, open the dictionary, search things, and all the Windows stuff. Don't have to worry about it. And actually, I don't understand that. So,
Why promising?
But then these are all the names being compiled. And that's the database. These are about 1,000.
So King, all you have to do is just put a name in,
Yes.
and you can get their sons.
Yes.
Okay.
You can get the sons and you can get the father.
Oh, the father, right, okay,
So from the father, you can go up.
okay, that's okay, so that's what when you execute the word, so you look at, the CFA will then say, okay, here's the father of this guy, here's the first son, second son, blah, 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 blah.
No, just the first son.
Just the first son.
So what you do is you get when you search all the records and you find and you get the father field, the address of father field, and the address of son, the first son field is 457.
Right.
Okay, so you only have these two fields. From the father field, we can go up.
And see.
To see his father, and when you find his father, we can find his grandfather.
Right.
And from his grandfather,
Okay, but now when you get to the first son, they say, well, is there any other, or like a second son?
Right. Right. You get the first son. You go to the first son.
Yeah.
Okay. And you would go look at his father. Is he of the same father?
Yeah, I see.
We have the father's CFA there.
Yeah.
So you can look up the father field. Are they of the same father? If they are of the same father, they are brothers.
Right.
So you go down the list until you find a different father.
Right.
And then it's it.
Okay.
Okay?
Got it.
So you see, the database is very simple.
Right.
You only have two fields. But it has a complete knowledge.
Right. Right.
I'd like to keep up. Okay, any questions?
I like also the other one, just a comment, I like the idea that you actually, fourth is not constrained in English.
No.
If you use Unicode, then it's usable for any language.
Yeah, you could put
So, that's the advantage of four. Four is not restricted to English.
Right.
Okay? And we often in Taiwan and China, we often talk about what's the primary programming language you have to learn. English. Right. Okay. That's a primary language. So this compare India and China. China is a disadvantage because the student has to go basically to college to learn computer science, because only in college they have enough knowledge of English to do that.
Okay.
India has the advantage that their primary language is English, so they can start way earlier.
Okay.
So you can see the Indian software engineers.
So now
all the top computer scientists in the valley, they are all Indians.
Oh, but
Ford
China's
can
catching up.
represent a gateway to Chinese speakers to gain valuable computer science. Because you said earlier that fourth is the language that you can speak in Chinese. So this has become weapon. So our existential enemy, Red China, what are we going to do with fourth now? What's going to happen to us?
Yes. 15 years ago, we saw a report in China. Oh, we've invented Chinese programming language.
Oh, excellent.
And we look underneath it. It's WinForm. Okay.
Yeah.
They just took WinForm and wrap it and then publicize that that's a Chinese programming language. And that's true because no other languages that can be changed so that you can speak Chinese as a native language.
Actually, one other family of languages that can do that is Lisp.
Yeah.
Fourth and Lisp are
So
And very similar. Yeah.
it's just Lisp is a name-based language, and then if you use Chinese names, this is Chinese programming.
Right. China has the numbers, though.
Okay.
They have the numbers. They're going to win.
I don't know. Chinese, you see, Chinese are at disadvantage.
True.
Because they couldn't get their English education.
Right.
Moreover, there's a cultural diminishment of creativity. Not Chinese culture, but the party culture. And it's like the photoelectric effect. You've got a sea of red light, and there are a few blue folk, but if they would be more like we are, they would certainly swap us.
Yeah. Just by numbers.
But remember, you can have all the red light you want.
So I think that I wanted to present this kind of I was advertising that this talk, this presentation is trilingual.
Yep.
In English and Chinese, talking about four.
Yep.
I had a question about
Yes.
the genealogy is the how canonical are the choices of friends look like? How good a job have you done of finding some a good match for the names? Are they trying to be sound alike? Or are they trying to be
The Chinese translation is based on
it's just sound? Do they try to be at all clever and trace the names?
is not possible. So the Chinese name was all based on phonetic.
And are they canonical across translations, or is it sort of?
Yes. The Bible translations are all versions are very faithful to the original people. The English, I think, mostly use the Hebrew characters. So all the Bible, different languages, different versions in different language, the genealogy are identical. Okay. So basically, you can. It's just that I picked the Chinese text as my base of analysis, but there's no reason I use English.
One note, Dr. Tang, is if instead of going by adjacent records for the sons, if you go that your link field is to the last son, then you can use the inbound linked, the current link field to trace back. That's a way of going variable length.
No problem.
Right.
Yeah, I think you can do it many of different ways. Or you can. First, I thought I have to create the data records in a separate area. Okay, and then the dictionary only points to the individual records in a different file or in a different area. But then I found that just the first son has enough information for to process this.
Right, and it does.
List of sons.
Yeah. It's going to the last son just fixes a little bit of a variable length name problem.
Yes, I think in the from the compiling point of view, having the last one give you the identity, you don't have to,
you have a little bit of an advantage there.
But I think.
Otherwise, it's great.
Information's there, then there's no problem. You can go either forward or backward.
Right. I like how you did that, though. That was neat.
Okay, let me see what I have there. Demo, I'll show you this one. And then these are the punchlines. What is the only Chinese programming language if all 4 words were given Chinese names?
You could.
And because the word set is very limited, very finite, very small. So giving each 4th word, each and every 4th word that Chinese name.
Yep.
Just change the language in Chinese. Defining new words to replacing an existing word list. This is natural intelligence, natural language. So all languages are based mostly. I think all languages you can say, or all languages are based on words, and all natural language. Words are defined by other words.
Yeah.
Okay? And so actually intelligence is that way. Because I think that there was a theory, the assumption that intelligence has to be based on language. You cannot think without a language. Okay? Language is intelligence, and 4th is natural language, and 4th is natural intelligence, much far superior than artificial intelligence. Okay. Genealogy in 4th. Genealogy can be conveniently compiled into 4 dictionaries as linked, simple genealogy words. Each word has only a leaf field, a name field, a father field, and a first son. So it's a very simple structure. For the interpreter, can search the dictionary and display genealogy. Okay, that's all. Questions?
Excellent.
comments?
Very
Okay,
good.
Thank you very much.
Very good. I love it. Yeah.
Okay, I think it's about time to lunch.
Well, I haven't go into it, it's all, that's what.
Okay,
Yep.
we'll go lunch.
We'll see
and
you
we'll
later.
Come back at 1 o'clock, right?
Something like that.
Something like that.
Whatever in the schedule.
We'll be back when we return.
Yes.
Yes, okay. Thank you very much. Talk to you later.
Yes.
It's Terrence Day, so shake a leg, get over there.